Okay. Let me go back one. And another. So these are all the fundamental data types. So it sounds like each of these is a fundamental data type. So I'm not sure how true this is. It does not define the exact size of any of the fundamental types. However, character and character 8 type are exactly 1 byte. Aren't those fundamental data types? Unless we're talking about the types only being integrals, non-integral, or whatever, void, float, and then the integrals. Sure, integrals aren't all the same. Maybe voids aren't. Well, that would make sense. Floats, maybe they aren't. Maybe it depends on how big the number is. I don't know. I guess it can't because it's defined before the value. So it has space. Like the bucket size is defined. You don't. It's not a bucket that changes the size depending on how much shit's in there. It says it doesn't define the exact size of any of them, but then it says that it does define for any of them. I don't know. All right. When we talk about the size of a type, we mean the size of an instantiated object of that type. Well, yeah, it makes sense, because if I start a function, I mean, the variables don't have shit right now. But once it's been instantiated, the compiler goes, oh, yes, Mr. Float. I have Mr. Character underscore T. Char 8 underscore T. Character 8-bit, byte, bit, 8-bit, yep. Underscore T. Here's 1 byte for you, sir. Now, get in. Sounds like that's how this is, yes. It's the instantiated object type. Get in. Okay. Alright, make some assumptions. Byte is 8 bits. Memory is byte addressable. Okay. Floating point support is something compliant. Okay. Some sort of regulation. We're on 32 or 64-bit architecture. Okie doke. We can reasonably state a bool is 1 byte. Okay. The minimum's a byte. Okay. The minimum, but it's not actually using the entire. Oh, I mean, it is using the entire byte, but it is 0, 0, 0, 0, 0, 0, 0, 1 or 0. It's not going to use anymore. It's only a Boolean. A pointer. 4 bytes. Damn. Okay. Oh. So a character gets no more than that, which is just like an 8. So carry is just a character basically, it sounds like. Minimum size 1 byte exactly. Character 16 is 2, 32 is 4, okay. So it specifies how many bits are in it. So there are ints that are 2, typical is 4 though. Okay. So I wonder what how this minimum changes. Does the bucket actually get shaped to the value? To a minimum of 1? And then it gets an extra byte if it needs more? Removes them if it doesn't? Or it just doesn't get less? Big number gets big. Small number gets small bucket. Okay. Seems like usually they just double. There's a double, but then there's a long double. Okay. So it could still be longer. Alright. Do not assume... Really? For maximum portability. Do not assume that they're larger than the minimum size? Wow. Oh, just because... Ah. Oh, because it's probably the case that they are about the minimum size. I mean, in this case, they're usually the same. They're almost exactly the same. So if this is most common, apparently these are reasonable. So maximum portability, don't overinflate. Some are bigger, sure, maybe. Maybe the minimum's bigger and it fucks up there, but it's fine. So we assume that they are not larger than the minimum. If we assume that a type has a non-minimum size, that it's at least 4. Says this is exactly, like some of these don't have to be exact. Okay, so I can do asserts to make sure, to get information from the system that I'm running on and fail so that the architecture there doesn't fuck things up. I'm getting a Zyrtec, I don't care. Oh, excuse me. Ugh. Man. Oh, that sucks. Alright, got a Zyrtec in, I'm good now. Should be. So, because the architectures vary, please, depending, the sizes of data types vary depending on architecture. We could figure out what the size is in a particular machine, and maybe I don't even need to know it. I only allocate what it needs to be. So on a computer with one type of architecture, I can say, hey, give me the memory that's this much, and it's the size of a character here. Don't tell me what it is, just give it to me. On another one, I can do the same shit, even though on one of them, an int is minimum 8, on another one, an int is minimum 4. So, okay. To determine the size of types on a particular machine, we have size of. Unary operator, okay. It's one parameter, sounds like. A type or a variable. Oh, okay, so I can give it a variable and it'll do the type. Okay, yeah. It returns the size of an object of that type. So it'll say, oh, x is an int, so I have int x. Size of x, it's saying size of x. What is x? X is an int, size of an int is pop. Okay. Oh. Okay. Okay. Setting width. Oh, because we're putting spaces in there? Alright, we'll just run this for... Well, okay, so... Do an IO stream for output. And it sounds like we're also getting this... This little guy here. So we're left justifying output first. Then we're outputting from here. Oh! Oh wait, no. We're left out... So we're... outputting... from here. I don't know why we do this first and then this. We say bool, but then right after it sets this. So I wonder why it's not bool and then set this for like a big space. And then this. I don't know. Okay. C limits, character limits for character bit. A byte is character bit bits. Oh. Okay. So we figure out how many bits are in a byte, and then we figure out how many bytes are in each of these things. Two, an int is 4, a long is 4, a long is 8, float, double, long double. Huh. Wonder why this doesn't change, yet this does. And this does. Kinda wanna debug it real quick, see what happens. Step in. Oh, it's been the output. Okay. I really don't want to do this. Okay. Shit, because it runs the entire line. I can't do it piece by piece. So it outputs what? We do set width or set W, float, and then size of float. But we're not doing anything where we are. It should just be like float, and then right after the number, and then right after the bytes. But instead. I don't know how that's working right now, I really don't. Okay. Alright, it's too fucking cold. They're too hot. Oh, these allergies, man. Alright, this music fucking sucks. Oh shit. All right. So we can use size of to find some shit. Okie doke. My shit was the same. Your results may vary based on compiler, architecture. Okay, makes sense. Architecture, yeah. Excuse me. Oh, excuse me again, sorry. Of an incomplete type. Huh. Okay. That's because it doesn't know how much memory to give it, so maybe it doesn't even give it memory, it sounds like. If it doesn't know how, it just doesn't. It just says that it's a thing, it stores it in some other way. Or stores some other defined amount, but it isn't defined? Huh, I don't know. Okay. Size of a variable name, alright. We're gonna do character output and we're going to insert. Four bytes for an int. Oh. What if I just don't do that and we do... Oh, I can't even use an incomplete type. Character? What if we do... Oh, well, that's it. Alright, cool. Sounds good to me. Size of does not include dynamically allocated memory. We will discuss that in the future. Okay, cool. Fundamental data type performance. Okay. Oh. Interesting. With this example, it makes me think that a 64-bit CPU is optimized to process 64-bit shit. I wonder if that's the case. Damn, dude. Alright, I think we're good. It's a good freaking towel, too. Whatever, I got extra towels. Signed integers. Positive and negative whole numbers including 0, yep. 4 primary fundamental int, short int, long int, long int. Minimum sizes. Oh, now we're talking bits, yo. Man, I thought we were talking about them damn bytes, man. 2248. C++ only guarantees the minimum size, not that it will have a specific size. Okay. Yeah. Well, yeah, because it depends on the architecture, yeah? Boolean characters are also integrals, yes. Okay. Alrighty. Please, a negative sign. -3, +3. Yep, and we omit that. That is the sign. By default, they are signed. It's stored as part of the value. Oh. Oh. So you could say if it's the... if we have a signed integer, it's 4 bytes, and it's getting half the negatives, half the positives. So if it can only go down this negative and this positive, those should be equal and opposite. Maybe? But I make him signed. I'm still allocating 4 bytes. It's just all positive or all negative. Maybe? Before it runs out? Because then we're not wasting space on considering the other sign. We'll focus on signed and unsigned next. That's cool. Oh! So signed can be either, but unsigned are only non-negative. Only positive, it sounds like. I don't know why they'd say only non-negative, but is that because it includes 0? Maybe. Non-negative is easier than positive and 0. Short, int, long, long, long. Okay. Prefer them because more typing, adding it makes it harder to distinguish. Yeah, because we see long int, and if I'm just reading quickly and I read int because I'm looking too far to the right, then I'll screw it up. Mistakes? Yep. Yeah, because then I think it has more space for bigger values than it actually did, or had less. I thought it was more accurate than it was. Or I thought it was less accurate. Optional signed. Sign short, signed int, sign long, long. Sorry. Should not be used. Oh. Oh, that's because, yeah. So we're not going to say signed because it's redundant. Yeah, it makes sense. It's like, it's just like saying positive, parentheses, +1. Yeah, we know it's +1. Just say +1. Okay. Do not use signed. Ah, it's a freaking piece of paper. Yes, because each bit is 2 more. Each one doubles because if I have 3 bits, 2 to 2. Let's say I have 2 values, but then I get 2 more. Well, I have those 2 values, but then I have one more thing that could be either or. So I've got these 2 when this is 0, and these 2 when it's 1. So I actually have 2 and 2. Oh, I have 8. Well, now I have another one. So there's 8, 0, 8, 0, 8, 1. So it doubles every time, so it's powers of 2. You add a bit, it's a power of 2 more values. Holy, it doubles it every time. I wonder why we said addresses earlier were only a byte. There were 8 bits. But that only goes up to, I was right, 128. Oh, wait. But it's fine, so maybe not. Hold on. Yeah. 128. There's more than 128 whatever variables or anything that memory would be allocated to in a program, surely. So, excuse me. Meaning, there aren't enough unique values here. There have to be more addresses than that. So I don't know if there are bigger addresses or how exactly they're unique. But we'll see. Excuse me. Still can't get that pepper. 2 in values, but which ones? We call a specific set of values it can hold its range. Okay, so Boolean range is 0, 1. Character range is whatever. A through question mark or something. A through space. The range of an integer variable is determined by 2 factors. Size and signed. Because if it's size, or signed, or size, bigger, 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 bigger. Signed, wider, 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 wider. Okay, we're only seeing half. That's annoying. Ape signed has those 2. Yep. Wow. Centillion or quadrillion, sextillion or something? Pentillion, maybe? Trillion, quadrillion, pentillion? Okay. Yeah. Yeah, so the positive is just 2 to the n minus 1. Oh, also true. 2 to the n minus 1. If I only have 1 bit, let's 2 to the 1, yo. 64. 2 to the 63. Because I already have 1. I'm multiplying it by itself 63 more times because I have 63 more than 1 bits. And then we subtract 1 at the end because it is 1 less positive. Makes sense? So 2 to 7. Minus 1. Minus 2 to 7. 2 to the 8 minus 1 I guess is better. O4? Okay. Appendix? I don't know. Required by the C++ 20 standard. 2's complement binary representation? Okay. Sign, magnitude, and 1's complement were permitted. Oh. So, same shit. Same shit, but it would be equal. So, oh wait, and -1. Ew, yo, are you serious? It's gonna be -129 to 127? That's disgusting. Yeah, looks like it. Okay. Overflow. $140 to 8-bit. So it can only hold. Oh, time to pause. Next one. Well, not pause, but keep going.